Okay. Okay, so let's say in general, for the first one, just like we proved before, for integrals, involving square root of a squared minus u squared, let u equals a sine of theta. Okay. So that means that square root of a squared minus u squared is going to equal a cosine of theta. For negative pi over 2 to pi over 2. Okay. Now for this to work, you're going to need one other thing. And that's your right triangle. And let that be your theta. Excuse me. Okay. Now we know that sine of theta, since we let u equals a sine of theta, that means sine of theta is u over a. Okay, which is our opposite over hypotenuse. So that's your u over hypotenuse. If you solve for this missing angle, it's actually square root of a squared minus u squared. Okay, and that triangle will actually come in very, very handy when we start doing the examples. So it actually serves a purpose. All right, so separate that a little bit and go to the second one. We're not going to prove the second one, we're just going to go right into it. It's pretty much proven the same way that the first one was. Okay. So what if we have integrals involving the square root of a squared plus u squared? Okay, so if we have a squared plus u squared, we'll let u equal a tangent theta. Okay. Then once we do that, the square root of a squared plus u squared will end up equaling a secant theta. Okay. Like I said, it's proven pretty much the same way the last one was, so that's why we're not going through it over and over. Okay, and that's for the integral negative pi over 2 theta is less than or equal to pi over 2. Okay, and once again, we're going to have that handy right triangle that will come in to play. Okay, let's this be your theta. Okay, so you want to note that tangent of theta is again u over a if you divide both sides by a. Okay, so that's one way to remember how to draw each triangle. Is instead of trying to remember each step, just remember sine is u over a, tangent is u over a, and secant will even be u over a. So you can kind of draw it from there. Okay, so tangent, which is opposite over adjacent. So you have your opposite over adjacent. And if you solve that using the Pythagorean theorem, it's a squared plus u squared. That a looks like a q. A squared plus u squared. There we go. A little bit neater. Okay, so now we do the very same thing. But what if we have integrals involving the square root of u squared minus a squared? Okay, before it was a squared minus u squared, so if they're switched around, it's a little bit different. Then you're going to let u equal a secant theta. Okay, so if you do that, then your square root of u squared minus a squared will come out to equal positive or negative a tangent of theta. Okay, that's for either the integral of 0 to pi over 2. Actually, it's just less than pi over 2 for this one.
Move it up a little.
Oh, sure. There you go. So it's just less than pi over 2. Or from pi over 2 to pi. Okay, so it's you're going to use a positive one, or positive tangent, a tangent theta, if u is greater than a, or you're going to use the negative if u is less than negative a.
Move it up one more time.
Oh, sure. Okay, and just like the other two, we're going to need our triangle. Okay, and just like before, first thing you want to do, just like with these two, you can always draw the triangle. Just remember that secant is equal to u over a. So secant theta equals u over a. Okay, so remember, secant is hypotenuse over adjacent. Okay, so you have your hypotenuse, which is u, over adjacent, which is a. So that actually makes this side square root of u squared minus a squared. Okay, so don't rack your brains trying to memorize it. It's best to just know how to draw it out. It's just a whole lot easier. Yes?
This was on the test we just took, right?
Nope, this one wasn't, because it's a little bit different. And
The top two were? Or am I like misremembering?
No.
yep, it's a little bit different. It's really, really close, and I'll show you how it's like a little bit different.
Gotcha, okay.
Yeah, they did involve that square root of like u squared minus a squared stuff, but those were.
Yep, just for the secant one, you had the 1 over x, and then those two u's had to match.
Mhm.
So these are different because those two u's won't match.
For the
So.
tangent one, there's a square root, or in the equations we were using before.
Yeah,
Correct.
yeah. So it's really small
Yeah.
differences.
I was losing my mind. I was like, wait a second.
Oh no, you weren't. It's really, really a really small difference between the two. Oh, let me move that up in case anyone's still. Okay, anyone still writing? Okay. All right, so let's say, for example, and move that down. There we go. We wanted to evaluate, dx over x squared, square root of 9 minus x squared. Now before, if your u was equal to x, that x would have to be out here also. So that's why it's just a little bit different. Yep, I hit my dx. Okay, so first thing we want to do, that square root of 9 minus x squared equals square root of 3 squared minus, of course that's x squared, is in the square root of a squared minus u squared equals a cosine theta form. Okay, so we know which one we're going to use. Okay, so we know here, that's our u, so our u is going to equal x. Okay, so if our u is going to equal x, we know sine of theta is u over a, which means that sine of theta is equal to x over a. So that means that x is equal to a sine of theta. So instead of u sine of theta, it's just x equals a sine of theta. Okay. So since we know A is equal to 3 here, okay, because remember that's still your A, and that's your U. Since A is equal to 3, we know that X is equal to 3 sine of theta. Okay. Now once you have that, you can actually use this, if you wanted to leave it as X over 3, to draw your triangle. Okay, so you're actually going to use your triangle to find X. Actually, we already have X, but we need that to find X squared and square root of 9 square root of 9 minus X and dx. Oh, actually, we already have that. Never mind. All right, so that means if you have your triangle, which we're going to draw right on out, okay, so sine is opposite of hypotenuse, so we know if sine of theta is equal to x over 3, opposite is x, over hypotenuse is 3, and if we solve for the missing side, it would be 9 minus x squared. So we know that x is 3 sine of theta, which means our x squared, I actually should do the dx first, since it's right next to it. Dx is equal to 3 cosine of theta with respect to theta. And our x squared is equal to 9 sine squared of theta. Okay. And we can also see that since cosine of theta is adjacent over hypotenuse, we can just use that to see our cosine of theta, which is square root of 9 minus x squared over 3. Okay. Which means that if we multiply both sides by 3, square root of 9 minus x squared is actually equal to 3 cosine theta. Okay. So it's a little bit of, I guess you can say, card shuffling going on, because you're using kind of everything you know to change everything in your original problem. Okay. So what we're going to do now is we're going to use everything we just figured out here, our x squared, our 9 minus square root of 9 minus x squared, and our dx. We're going to replace all of those with what we have here. Okay. So we know where dx is 3 cosine theta with respect to theta. Over your x squared, which we know is 9 minus sine squared theta. Nope, 9 times sine squared theta. Wrong one. Okay, and we know our 9 minus, well, square root of 9 minus x squared is 3 cosine theta. Okay, so the 3's cancel each other out. Okay, so we actually the cosines cancel each other out too. So if we factor out that 9, so we have that 1 over 9, 1 over sine squared theta with respect to theta. Okay. Really, that's just the integral of cosecant squared. So 1 over 9 cosecant squared theta with respect to theta. Okay, so we know the integral of cosecant squared is just cotangent. So you have 1 over 9 cotangent theta plus c. Okay, so that's actually not your final answer. Your final answer will be once you use the triangle to translate that back to function of x. So use your triangle to convert, to a function of x. I don't know if we can call it a function, but we'll just call it a function. Okay, so we know that, put that in over here, that if tangent of theta is equal to opposite over opposite over adjacent, sorry, then cotangent is adjacent over hypotenuse. Opposite, why do I keep wanting to put hypotenuse in there? There we go. Okay. So adjacent over hypotenuse is square root of 9 minus x squared. I said hypotenuse again. Over x. Okay, so you have 1 over 9 times square root of 9 minus x squared over x plus c. Move that up a little bit. Okay, so simplifying that is just square root of 9 minus x squared over 9x plus c. Yes?
Would all the stuff involving cotangent be negative?
What do you mean negative?
Literal cosecant squared is negative tangent.
Oh, did I leave out the negative? Yep, I guess I did leave out the negative. Yep, so it would be negative. All right, any other questions on this one? All right, I'll leave that up for a little bit. And we'll do another example. Everyone's still writing. Oh, looks like everyone's done. Oh, wait till you get to Diffie Q. Oh man, that's the fun right there. There are some proofs that'll fill up these boards twice for one proof.
I'm good.
Okay, so if you evaluate, say dx over square root of 4x squared plus 1. Excuse me. All right, so for this one, we're just going to rewrite that one. So square root of 2x squared plus 1 squared. In this case, your u is equal to 2x. And your a is equal to 1. Is in the form square root of u squared plus a squared equals a secant theta. Okay, so we can actually draw our triangle. With our theta. Okay, so remember that tangent theta is going to equal u over a. Okay, so our u is equal to 2x, and our a is equal to 1.
Tangent. Why are you looking at tangent? Where do you see it?
Nope, tangent. Yes.
Your u squared plus a squared, I thought that
Nope. Oh,
equals-
it is secant. You're right.
Yeah,
Yeah.
a tangent theta, right?
Okay, actually, this should be.
No, it should be.
U
U squared
equals
plus a
tangent
squared
theta.
is a form of a tangent theta, not secant theta,
Yeah,
right?
it is tangent. What am I talking about? I'm not listening to y'all.
You have to change the.
No.
I know.
A secant theta has to be changed to tangent.
That square root is actually tangent, not.
Yep, that's tangent. Okay. I'm glad I listened to y'all. There we go.
Cool. one of the two spots was wrong.
Yep, I should have known when I drew that tangent there. I should have paid attention on that anyway. All right, so our tangent is u over a. So if you have u, which is opposite over adjacent, so you have your 2x over 1. So that would end up giving you 4x squared plus 1. Make that so I don't. All right, so once you do that, now you use your triangle. Bless you. To find your dx and your square root of 4x squared plus 1. Okay, so remember, once you draw your triangle, you're just going to use it to replace everything up there. And then you're also going to use your triangle to convert whatever the answer is once you get done. Okay. Okay, so tangent theta, which is opposite over adjacent, that means your tangent theta is going to equal 2x, which means your x is equal to 1/2 tangent theta. Tangent theta. Okay, so we have our x, which means we have to find our dx. That means your dx is equal to 1/2 secant squared theta with respect to theta. Okay, so we got one of them out the way. Okay, so now we have to find our 4x squared plus 1. Okay, so actually, secant theta equals square root of 4x squared plus 1 over 1. Remember, cosine is adjacent over hypotenuse. So secant is hypotenuse over adjacent. Or hypotenuse over adjacent, square root of 4x squared plus 1. Okay, so now we know our secant theta is just the square root of 4x squared plus 1. So we have our dx, and we have our 4x squared plus 1, square root of 4x squared plus 1. Okay, so now we just start replacing stuff.
Where did you get the secant?
Oh, because I wanted to find our square root of 4x squared plus 1. So that meant square root of 4x squared plus 1 over 1 would give me that. So if you had a 2 there, then it would have been square root of 4x squared plus 1 over 2. Then secant theta would have just been 2 secant theta.
Okay. Yep.
Does that make sense? All right. All right, so now, like I said, we just start replacing stuff. So integral of dx over square root of 4x squared plus 1, we're going to make that the integral of your dx. Remember, that's 1/2 secant squared theta d theta over square root of 4x squared plus 1 is just secant theta. All right, so that 1/2 can just come right on out. And that just leaves you with secant squared over theta over secant theta with respect to theta, where one of those just cancel out. So you have 1/2 the integral of secant theta with respect to theta. Okay, and the integral of secant theta is the natural log of secant theta plus tangent theta, absolute value. Natural log secant theta plus tangent theta plus c. Oh, sure. There we go. All right, so once you get that answer, now you just use your triangle to convert those two. Use the triangle to convert tangent theta and secant theta. All right? So we know that secant is hypotenuse over adjacent. You have 1/2 natural log. Hypotenuse over adjacent is square root of 4. What? Square root of 4 squared plus 1 over 1. So it's just square root of 4 squared plus 1, 4x squared plus 1. There we go. Plus, tangent is opposite over adjacent, so you have square root of, yep, I was right. 2x over 1. So it's 2x plus c. Actually, that would be your answer. All right, so any questions on that one? I know it's a little bit tricky. Yes.
You slide up to the triangle.
Oh, sure. Mm-hmm.
It's
Oh, all right. All right. Okay, so let's say, for example, we want to evaluate the integral.
Your timer's gonna go out in 3 minutes.
Oh, yep, might as well stop it now. Actually,